Good morning, grade 9. I hope you have a good day today. Welcome to your geometry class. Our lesson for today is the polygon angle sum theorems, textbook pages 353 until 358. The objectives is to find the sum of the interior angles of a polygon and to find the sum of the exterior angles of a polygon. But before that, let us first take note of some important points. What are polygons? So polygons are plane figures with at least 3 sides and angles. Now the interior angles are angles inside a polygon, and exterior angles are angles outside a polygon and are made by the extension of its vertices. Let's have here some examples of polygons. Its name, the number of sides, and the number of angles. First thing we have triangle. Of course, it has 3 sides and 3 angles. Quadrilateral with 4 sides and 4 angles. Pentagon with 5 sides and 5 angles. Hexagon with 6 sides and 6 angles. Heptagon with 7 sides and 7 angles. Octagon with 8 sides and 8 angles. Nonagon with 9 sides, 9 angles. Decagon with 10 sides, 10 angles. And generally, for any n sides and n angles of any polygon, we call them by n-gon. So let us start our lesson by watching this very informative video.
What is the formula for the sum of the interior angles of a polygon? To figure this out, let's start by looking at 3 separate cases. Let's see if we can figure out the sum of the interior angles of each of these polygons. To do that, we need to do some exploring. So, let's play around with each one of these polygons and see what we come up with. Here, let's draw diagonals through each one of these polygons. To do that, we need to start at one of the vertices of the polygon and then draw diagonals through it, a line to each one of the other vertices that does not sit next to the original vertex. So in this polygon, we can start with this vertex and draw a diagonal here. Then, here we can start with this vertex up here. And we'll draw a diagonal right here and another diagonal right here. Then in this polygon, we can start with this vertex up here. And we can draw a diagonal right here, here, and here. Perfect! Now let's see what happened. Starting with this polygon, let's see how many sides it has. If we count, we can see that this polygon has 4 sides. Now, with this 4-sided polygon, we drew one diagonal. And look at what was created. We have a triangle right here and another triangle right here. So, by making one diagonal in a 4-sided polygon, we were able to create 2 triangles. Now, what about our other polygons? Well, if we count the number of sides in this polygon, we can see that it has 5 sides. We drew 2 diagonals. And if we count, we can see that we created 3 triangles in this polygon. Finally, looking at this polygon, we can see that it has 6 sides. We drew 3 diagonals, and that created 4 triangles. Now look, I think I see a pattern. Here, a polygon with 4 sides is made up of 2 triangles. A 5-sided polygon has 3 triangles, and a 6-sided polygon has 4 triangles. So, the number of triangles in each polygon is 2 less than the number of sides. Now, since we're trying to find the sum of the interior angles of each of these polygons, and because each of these polygons is made up of triangles, let's take a look at that triangle sum theorem. Maybe that can help us. Well, the triangle sum theorem states that if we add all the angle measurements of any triangle, those interior angle measurements will always sum to 180 degrees. So if we take this triangle here and add up all the individual angle measurements, we will get 180 degrees. Always. So let's take a look back at this four-sided polygon. Let's label the different angles. Here we can have angle 1, angle 2, then we can have 3, 4, 5, and 6. Now we have two triangles here. We can use the triangle sum theorem to find the sum. The measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. So, this triangle, the interior angle measurements will add up to 180 degrees. What about this triangle? Well, if we add up those measurements, again, according to that triangle sum theorem, we will get 180 degrees. But our polygon is made up of two triangles. So if we take these two measurements and add them together, 180 plus 180, we get 360 degrees. That is the sum of the interior angles of this particular polygon. And we could rewrite this too. 180 plus 180 is the same as taking 2 times 180. Now look, 2 is the number of triangles in this polygon. So we would need to take the number of triangles in the polygon times 180 in order to get the sum of the interior angles. And this would work for our other two polygons as well. If we take 3, the number of triangles, times 180, we would get the sum of these interior angles. Here we would need to take 4 times 180 in order to get this sum. And in fact, that works in general for any polygon you're talking about. So we can actually write down a formula to find the sum of the interior angles of a polygon. Let's have the variable n be the number of sides of our particular polygon. That means, following the pattern we saw in step 1, n minus 2 is the number of triangles that make up that particular polygon. Here is our formula. The sum of the interior angles of a polygon is equal to n minus 2 times 180. Here, we can use this formula to help us find the sum of the interior angles of any polygon. So now we have the formula that we were looking for. To find the sum of the interior angles of any polygon, we can use this formula to quickly find that sum.
Okay, so as a recap, the formula for finding the sum of the interior angles of a polygon is the quantity n minus 2 multiplied to 180, where n is the number of sides of a polygon. Now the next video will show you the solution of problem 1.
In this problem, you will find the sum of the measures of the interior angles of a polygon. What is the sum of the interior angle measures of a heptagon? Use the polygon angle sum theorem. How many sides does a heptagon have? A heptagon has 7 sides. So substitute 7 for n. Subtract inside the parentheses. And multiply. The sum of the interior angle measures of a heptagon is 900.
Let's answer page 353. Got it 1a. What's the sum of the interior angle measures of a 17 bar? So again, the formula for the sum of the measure of the interior angles of a polygon is the quantity n minus 2 times 180. Since the given is a 17 gon, meaning the number of sides is equal to 17. So substitute n is 17 minus 2 multiplied by 180. And 17 minus 2 is 15 times 180. That is equal to 2,700. So therefore, the sum of the interior angles of a 17 gon is 2,700. Okay, 1b. The sum of the interior angle measures of a polygon is 1,980. So how can you find the number of sides in the polygon? So we have here the opposite way. The sum of the interior angles is given. We need to find how many sides does the polygon have. So from the formula, the sum is equal to n minus 2 times 180. We will substitute for the sum. 1,980 is equal to the quantity n minus 2 times 180. Now here, the first step is to divide both sides by 180. So 1,980 divided by 180 is 11 equals n minus 2. To find the value of n, we will add 2 to 11, so n is 13. Now what was our process? So first thing what we did is we divide 1,980 by 180 and then add 2 to find n. Let us first take note of some important things. An equilateral polygon is a polygon with all sides congruent. An equiangular polygon is a polygon with all angles congruent. And when you say a regular polygon, it is a polygon that is both equilateral and equiangular. Okay, let's have problem 2.
In this problem, you will use the polygon angle sum theorem. The housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? How does the word regular help you answer the question? The word regular tells you that each angle has the same measure. Remember that you can use the corollary to the polygon angle sum theorem to find the angle measures of regular polygons. Use the corollary to the polygon angle sum theorem. A regular hexagon has 6 sides, so n equals 6. Substitute 6 for n. Simplify within the parentheses. Simplify. The measure of each interior angle in one hexagonal facet is 120.
So again, as a recap, the measure of an angle in a polygon is equal to the formula quantity n minus 2 times 180 divided by n, wherein again n stands for the number of sides. So let's answer page 354. Got it too. What is the measure of each interior angle in a regular nonagon? So again, the given polygon is a nonagon. So the measure of an angle is equal to the quantity n minus 2 times 180 divided by n. Since it is a nonagon, so therefore the number of sides is 9. So replace the value of n. Then simplify. 1,260 divided by 9 is 140. So meaning to say, the measure of each interior angle in a regular nonagon is 140. Let's discuss problem 3.
In this problem, you will use the Polygon angle sum theorem. What is the measure of angle y in pentagon TODAY? How does the diagram help you? You know the number of sides and 4 of the 5 angle measures. Use the Polygon angle sum theorem for n equals 5 to find the sum of the measures of the interior angles of the pentagon. Substitute the values for the given measures of the angles. Then simplify each side of the equation. Subtract 470 from each side to solve for the measure of angle y. So the degree measure of angle y equals 70.
Okay, page 355, got it 3. What is the measure of angle G in quadrilateral EFGH? So we are given that angle E is 85 degrees, F is 120, G is a known, and H is 53 degrees. What is the measure of angle G? So we will add all the angles inside the polygon. So the measure of angle E plus the measure of angle F plus the measure of angle G plus the measure of angle H is equal to the sum of its interior angles, wherein we don't know how many degrees is the interior angles. So we are just going to put the formula for the sum of the interior angles of a polygon, which is the quantity n minus 2 times 180. Then substitute the values. Measure of angle E is 85, angle F is 120, plus angle G is still unknown, angle H is 53, equals the quantity 4 minus 2, since it is a quadrilateral, so it has 4 sides, multiplied to 180. Now simplify. Measure of angle G plus 258 is equal to 4 minus 2 equals 2 times 180. So the measure of angle G plus 258 equals 2 times 180 is 360. So the measure of angle G is 102. So therefore, the measure of angle G is 102 degrees. Look at the illustration that we have here. These are the red degrees, or the red measurement denotes the exterior angles. So what can you say about the exterior angles of the first figure? So that is 80 plus 130 plus 150. If you add them, they are all equal to 360. What about on the second figure, which is a quadrilateral? The exterior angles were drawn. That is 115 plus 75 plus 99 plus 71 equals 360. Therefore, as a conclusion, you can say that the polygon exterior angle sum theorem states that the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So if we have here a pentagon, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 is equal to 100 and again, it's 360. Okay, so let's answer 355, problem 4. So what is the measure of angle 1 in a regular octagon at the right? So that is an octagon. We know that the exterior angles of any polygon has the sum of 360. So meaning to say 360 divided by 8, since an octagon has 8 sides. So the measure of angle 1, or all of those exterior angles, are 45 degrees. Now got it 4. What is the sum of an exterior angle of a regular nonagon? So again, it's a nonagon. So from the formula, that the measure of an exterior angle is equal to the total of 360 divided by n for the number of sides. Since it is a nonagon, so 360 divided by 9. So that is 40. So the measure of an exterior angle of a nonagon is 40 degrees. So I hope you understand our lesson for today. You can now answer your exercises and homework independently. Good luck!